all for coming. It's going to be a fun chat. We have a big panel here of very interesting people who backstage made it very clear they did not like the title of this panel because they cannot, I think nobody likes the term AGI. And Ilya, I'm going to start with you because you're somewhat responsible for this whole thing with the attention paper. So why is AGI so difficult to define?
Well, it effectively, kind of vibe definition, let's just say, is that it's as good or better than any human at any job. And the problem is, like, it's really hard to benchmark that. It's really hard to evaluate it. And as a machine learning people, we don't like that. And so, at the same time, there's types of jobs where it's clearly, coding, for example, where we can evaluate it, and it's already in some tasks are better than human. Right, and in some tasks worse, and so it's really hard to kind of draw this line very well.
Okay, so we're all racing toward this thing that we can't define, but so far what we've seen is that as you build, and again, thanks to the attention paper and other breakthroughs in research, as you add compute power capacity, you add data, you just tend to get this more powerful AI. Do we think that it's going to continue along that trajectory? Is it just more power, more compute, more data? I'll go to you, Chase.
It seems that way right now. The scaling laws, seem to continue to hold, and with each order of magnitude scaling factor that we're seeing in terms of cluster size. And data, we're seeing dramatic improvements. There's a lot of interesting things happening on the modeling side of this, and I think what's really been sort of fascinating to sort of watch is this whole chain of thought reasoning models and this shift from a lot of the computing power being on training side to actually just a massive amount of computing power on the inference side for the test time compute scaling, where the model's actually taking a result from tokens being fed into these large neural networks, and then sort of thinking about those results and sort of breaking down and going through a different decision tree of various outcomes to come up with a smarter and more intelligent result. And all of this is taking just a lot more computing infrastructure. So more chips, more data centers, and more power to make it happen. I think that's a trend that we're going to continue to see. And I think in all of our discussions that we're having with a lot of the leading labs, I think that is the bet that they're making, is that everybody, it was kind of like Elon, deployed this 100K, Hopper cluster. Now everybody wants, 10 times bigger than that, right? Everybody wants a gigawatt campus. Everybody wants 5 gigawatts. It's the scaling is pretty crazy. And to put that in perspective of like how much compute capacity 5 gigawatts is, a lot of people, most of the internet runs in Northern Virginia. It's kind of like, sort of seen as like the data center mecca, like center of the world. Well, end of 24, the total compute capacity in Northern Virginia was 4.5 gigawatts. So people that are talking about building these 5 gigawatt campuses, that's an entire Northern Virginia that we've been building for the last X number of decades to be built for a single compute customer in a single location. So just to give some perspective on the scaling that we're seeing.
Well, do we all agree on that? I mean, is that the route that we have to take? Go ahead.
No, to a large extent I would agree, and of course now since last year we've been part of AMD, and as part of that we are involved in building some of these large data centers
together.
Yes, indeed. But I mean, I do come from this sort of machine learning paradigm, which started like, I don't know, 5 decades, 6 decades ago, and I still think that we're still in the same paradigm where these machine learning algorithms are function approximators. You could say they do A to B mappings. And while we're seeing AI get this horizontal capability, which indeed sort of brings something new and has brought something new in the past few years, I think it's still, while we see and approach the horizontal capability that we would call AGI eventually, there's just tremendous opportunity in a wide range of different modalities. And I still think that what we're seeing happening today in these frontier labs is just one part of the story. And it will continue in many different waves in different modalities, be it life sciences, be it automotive robotics, be it visual media, entertainment and gaming, and so forth. So I still think that AGI is not just one concept.
Can I disagree with that? Or at
Yes,
least add some
please.
qualifications? So I think the question of is scale all that matters? Scale contains a lot of different dimensions. So there's the dimension of compute, how much compute you throw in at training time. And there's also the scale of the data set that you're training on, as well as how you're generating that data or procuring that data set. And for us, so SourceGraph is a developer tools company, and we're building a coding agent called AMP. And so AMP uses all the frontier models, so Claude 4, Gemini, O3. We try to sample as much of the landscape of the frontier as possible. And one of the things that we realized is that it's not always the largest model that performs the best. And I think what it comes down to is if you scale the compute of your training process or the scale of your model ahead of the data set that you have to train on, you can actually end up over-parameterizing or overfitting that training set. And so an intuitive way to think about that is, if you gave me the largest brain in the world that allowed me to literally memorize every single fact and gave me the Encyclopedia Britannica and said here, train on this, the easiest thing for me to do with all those neurons would just be to memorize the book without learning any sort of general rules or logic. And that does seem to have happened with the training processes of some recently released, very large models, where they score very well on the benchmarks because they're absolutely gigantic models. But the way they constructed the data set, it just didn't unlock these kind of latent capabilities that we associate with intelligence. And that's especially important in the coding domain, because making coding-based AI applications and agents work, a lot of it is leveraging some of the quasi-logic or reasoning skills that the models learn from the data set. So I agree with you on one side of things, which is the dimension of data scale. I think there's still a lot left to pursue, but compute alone, I don't know. I don't know if you agree.
Well, it's a trade-off, right? If you look at the fixed size of the model, like a 7B model over past 3 years, the quality of that model keeps improving, right? And so at a fixed size, we learn how to train better this specific model. But the way we're training it is actually by synthetically selecting data, using previous models to distill, and so it does all require compute. So it's just more complicated than hey, let's throw more chips. But at the same time, it requires actually combining all those methods and improving the training process through using more compute, through using more data and model architecture.
So I want to ask a little bit about what the AGI world, if we can even agree on what AGI is, looks like. And Sarah, you're at Lattice. I think you have a good vantage point because you see kind of the employment landscape, and that is one thing that everybody I think is concerned about, or at least thinking about. What are we going to have jobs? What are you seeing right now, and what do you think the future looks like?
Yeah, it's the number one question as we chatted when you're talking about AGI. What is it? No matter what it is or how you define it, the human reaction is, what does this mean for me, my jobs, my children's jobs, our society? And while we talk about how many gigawatts or the size of the data center or how fast or big anything is, the most important thing that we need to think about is how successful people are going to be with this new incredible technology, how people can be successful together with it, whether it's AGI or just a regular agent as we're working with today. And so what are we seeing in the workforce of tomorrow? We're all at the same starting line right now. We are all defining what tomorrow is going to be. And so it's going to be very different. I think we all know that. And we all have to focus on not being afraid of it, but really how we learn and how we help each other embrace it in a way which we're doing it responsibly and transparently and with accountability to ourselves and to society for the outcomes that we're going to be creating. So every job is changing. Every company's strategy is shifting. You're seeing new companies being born. I mean, this is such an exciting conference where the next Microsoft is right here in the room. And it is a time which is exciting, but we also have to be mindful for how people are going to be successful with this incredible technology.
Ilya, does it matter how the AI is built to sort of ensure this kind of future? In other words, like, there's a few companies that can afford to build these 200,000 GPU clusters. You're working on decentralizing this, right?
Yeah, so thank you for the prompt. So from my perspective, we kind of moving into this world where the way we interact with computing is going to be AI powered, right? AI is going to be the medium how we interact with computing, with services, and with each other, right? And this will, manifest into different operating systems that probably doesn't have apps, and it's going to be able to, predict what you want and be able to do things on your behalf and make decisions. And the challenge was that if there's one company that effectively provides you the service, that company is effectively dictating what things you can decide and you cannot decide. And so that's a very much like Orwellian, 1984 future. And so that's where, what kind of we coming from, how do we build a more community-owned, user-owned future where this AI models and the systems built on top of them are really kind of benefiting individuals, their well-being, their economic success, and not just kind of work on behalf of, for-profit corporation. And, that requires, blockchain technology, hardware, models, researchers, everyone to come together, right? It's not a kind of simple task, but it is a different mode of, and principle and kind of philosophy of how to build the systems.
So what does that look like? Is it open source? Is it the training is decentralized? The inference is decentralized? Does anyone else have a view on that? It does. Yeah, go ahead.
So maybe from my perspective, I think I think when we look at these very large training clusters, they're sort of like diamonds, in that, like, if you have like 10 1-carat diamonds, that's not worth nearly as much as one 10-carat diamond. And the reason I say that is that because basically a very big integrated cluster, you can kind of think of as a giant supercomputer with this shared memory layer where all of the compute is sort of acting in service of one workload. From that perspective, the very, very big clusters, they really need to be centralized. There's like no other way around it. They're all kind of unique and very, very big. And those are kind of the places where a lot of these like breakthrough foundational models get created. I think when we look at inference, I think that can be a lot more widely distributed. It can be way more widely decentralized, where we sort of see a future where inference is sort of happening everywhere, and is, as we have intelligence embedded in nearly every aspect of human life. So I think that way more easily lends itself to more decentralization, especially with advances in privacy-based computing architectures as well. Yeah.
Okay, another question for you guys. Is AI going to turn our brains to mush, do you think, once we get to AGI? We're already hearing this. It's in the zeitgeist, right? And like, Biang, you're seeing this, I think, with coding, right? Every coder is writing their first draft in AI now. Are we just not going to know how to think at some point because of this?
Yeah, so it's funny you should mention that. I think AI probably writes around 95% of the code I produce nowadays, and I would say I'm not like that wide outside the standard deviation on our team and among the user base of AMP. And so the other day, like, one of our inference endpoints went down, and so it stopped working for a bit. And I had this moment where I'm like, oh, you mean I gotta like write code by hand again? No thanks. I'm gonna go like, go out to lunch, and when I come back, maybe it'll have fixed itself. And sure enough, it had. And I was like, yeah, thank God I didn't have to do that. And so I'm sure there's part of my brain that was very attentive to that sort of like inner developer loop that has already atrophied to a certain point, at least to the point where I'm annoyed now if I have to like activate that region of my brain again. But I think, as with general technology trends, it's like you get dumber in some ways. Like, who among us knows how to like find a book in a very large library these days? Google sort of obviated the need of that. But we got smarter in other ways, right? Technology makes it so that we don't have to allocate our brain cycles to these lower level, more tedious tasks, and it frees us up to kind of go higher level and discover how to use our brains for these more valuable creative tasks. And so I still think a lot every day. I think more about like systems design, more about user level problems, and more about the architecture than I used to, simply because I have the time to think about that.
I mean, Peter, do you think that, at some point AI actually trains these models, like becomes up with the algorithms and the frameworks for the next attention paper or the next breakthrough?
No, I mean, in the same way as you highlighted, you using AI for programming, I think it is a reality that AI will play a key role in machine learning research and data science as well. I'm not sure it will give us the next Nobel Prize. So I think that's a debate that is ongoing.
Well, it have given us 2 last year.
Yeah, indeed, but in a little bit of a different way. So coming up with actually new knowledge is something which is uncertain. Others are of the opinion that we will get there, or we're already there. Others are of the opinion that we will never get there. But I mean, I'd like to come back to what, Sarah, you highlighted, and kind of what you said earlier on this impacting our everyday life. I think that's a reality, and the way I look at it is that this is democratizing and giving everyone the tools to be at a certain level, and in that way, I do think that it actually can have a significant positive impact on society. But at the same time, I think every single individual needs to rethink how they add value on top of that. And that's going to look very different going forward. It's not the same way that you did earlier.
I have this kind of statement that I think everything where we care about the outcome will get automated, and the things where we care about the process will be still kind of up to us humans to do. To give you examples, are sports. Like, we don't really care, that much about the outcome. We care about the process of the people playing sports. Like, you don't care that robot can score from any position on the field, right? The goal. Gaming, same. Like, computers can play games now better than people. We still way more enjoy, 2 teams battling each other at video games. Religion and many other kind of things where we enjoy the process, or we engage in the process, or we contribute to the process, where the process itself is a value, not the destination.
I'll disagree that I do think the outcome of my sports teams winning is important. Joking. But to the point of the outcome for people, you're starting to see these studies, whether we are losing intelligence because the intelligence is done for us, or what the outcome of a company is when you staff a company with just AI agents and you press go and see what happens. And right now, those companies, like Carnegie Mellon did this study, and it imploded. Dario himself had the blog project that was shut down because you generate a lot of content, but if you don't have people reading that content, if we're just robots talking to robots, what society have we built? But to the optimism, yes, like there are students that are able to have learning that is customized, tailored for them in their language, in their way that they would choose to understand. There's some people, for example, when you think of fitness, some people like drill sergeants that are like, drop and give me 20 right now. And then other people that like more yoga, Zen instructors. And you're seeing this, I believe it's in Texas in the United States. They have students that are learning for a few hours with the AI tutor, and then the teacher, the human teacher, takes them outside and teaches them practical knowledge like playing store or jumping rope, and they're testing top percentile. And so the more that we can democratize and give access to those that haven't had it before and use it to make ourselves better, greater, because it's personalized for us, then that is a much more utopian outcome, but we have to hold ourselves accountable to that.
So I want to talk about what's standing in the way of this goal. It sounds like you all are mostly positive on the outcomes. Maybe there's some negative side effects, but what are the bottlenecks for getting to AGI? I mean, I can think of a couple right now, like energy for one, and regulation. But I'd love to start with energy, Chase. I mean, I think you're well versed in this topic. Like, and there's a big summit next week in the U.S. and Pennsylvania about this. Trump is going to be there. How much energy do we need, and are we on track to meet the demand?
Yeah, I mean, I was sort of describing this earlier in terms of the scale of people are throwing around gigawatts pretty loosely in a lot of discussions these days, and I think it's important for people to recognize just how much power that is. I mean, that's like a nuclear power plant worth of energy for a data center. So, we are increasingly seeing this kind of convergence between energy and computing as we think about sort of the scaling laws being preserved, and we're going to need a lot more energy to sort of make the future happen, and we're going to need a lot more energy to make AGI happen. And I don't think that's a bad thing. I think it's an important challenge of our time to sort of facilitate this new era of AI-driven abundance through energy abundance. And I think one of the things that helps me, as I'm very much an optimist about the potential future for AI, is that I think AI is going to unlock an incredible amount of new energy innovation as well along the way, in terms of it, being a tool for invention. So you're seeing things like trying how do we invent new battery chemistries to make grid scale battery storage more cost effective, and work more cohesively with renewables. How do we use AI to as a tool for invention to help accelerate a future of ultra low cost fusion to provide abundant clean power for society.
And how do we think our leaders are doing on this subject? Does anyone?
I mean, I think there has been a very welcome shift that's been very positive on nuclear in the United States. I mean, I remember in 2021, I was working on this nuclear-powered AI data center that I wanted to bring to life. I brought it to like literally every big tech company, and everybody's like, nuclear, can't touch that. That's like it's got a stigma to it. Then of course, they added nuclear production tax credits to the Inflation Reduction Act, and suddenly nuclear became very, very cool. And then SMRs kind of came along, and and this was like not that long ago, right? This was like 2021. I think the shift on nuclear makes me like incredibly optimistic. I think the current administration in the United States is like pushing nuclear very heavily, which I think is a very exciting sort of turn. And we're learning from our friends here in France what a great resource nuclear energy can be to power the economy.
And do we think? I mean, Ilya, you might have thoughts on this. Is regulation a hurdle, do you think, in the U.S. or Europe or anywhere else?
So, I mean, I think the challenge that regulation takes time, it takes education on the regular side, and this technology is moving so quickly that there's always, like, the lag is, like, there was regulation in, over a year ago in US where, if you train above this model size, or this above this floating points, like, it's just like, they were trying to regulate things that like are such a moving target that like researchers came up like 6 months ago, and 6 months later somebody will come up with something else. So I think the challenge is like the regulation by government is probably not the right instrument, and we need a different kind of, I call it regulation by product or regulation by design, where we can actually have, if you assume, for example, that safety is an alignment of this model, so it's extremely important that we don't want, everybody to be able to design, bioweapons with this. Well, we probably need to, build a system where you cannot actually access the model weights without that, right? Like you have indeed confidential computing. The model trained actually ends up, encrypted and only decryptable in confidential computing mode. And then the whatever safety and security apparatus that's applied is applied on that level, not on, hey, did you certify that and did you file the paperwork, and like was there like external committee that evaluated the model. So I think we need a lot more of that, and kind of building systems that are really bringing those properties to life. And I think, again, decentralization from my perspective is more of a tool where it's needed. Indeed, if you need to train a model on a million GPU cluster, there's no decentralization to do that, right? But you can make sure that that whole cluster is in confidential computing mode, that there's no individual organization can access what's happening inside, and the outcome is now available to everyone, but with the permissions and security analysis that everybody agreed with, right? So that is kind of approach. I don't think the regulations tomorrow coming out and saying everybody should be in security enclave will be able to kind of achieve that, though.
I mean, does anyone think we need more regulation? Does anyone on this panel? It sounds like you're fairly anti. I mean, do you think it's holding back Europe, for instance? I mean, we talk about that a lot in the U.S.
Yes.
It's as simple as that.
I think it's less, there's regulation, but there's also education. And you asked like what barriers could be. This is affecting every human on the planet. And it is something which people are not educated about what it is. On a panel of experts, we are not able to define it yet for you. And so if we cannot define it, agree upon it, educate the whole planet population about it, there will be fear, there will be uncertainty, and there will be doubt. And when there is that FUD that exists, it will be hard. It will be an obstacle to overcome. So the amount of education and the change management with the people is, in my opinion, not talked about enough, and very much underestimated in terms of the amount of work that will entail.
Yeah, so I think, we're based in Europe, so and I've been looking at this sort of process that was kick-started in 2017, and of course the EU AI Act is not the only regulation that is a concern in Europe. So, but to be fair with the EU AI Act, where it started in 2017, which was about regulating systems and methods and technologies, I think we've come pretty far. So Europe is not regulating AI as sort of one thing. And now we're eventually the EU AI Act, and I think we should be fair with the fact that where the EU AI Act is much better than where it was in 2017 when the high-level expert group started to work on it. And it's use case specific, and it has different risk categories, and for most of the different use cases, it takes a very different approach, which are not high risk. But then I do think that as a final step in the process, the Commission introduced the GPAI category, which I don't think anyone has defined. I guess it's been defined as well as we defined AGI. So, there I think we have question marks, and now this has been an ongoing dialogue in the past few weeks on whether there will be a pause or not, and I think the decision now a few days back was that there will not be a pause, and the Commission will move forward. But I do think that we still have question marks with the GPAI category. I don't still think that that's the main reason why Europe is not innovating.
What is the main reason? And are they not innovating? There's a lot of great companies here.
I've used I've used Paris as a good example of Europe innovating. So, being here, I don't want to be too negative. I think the AI ecosystem in Paris is showing example for others in Europe to follow. Now, there are many reasons, but I think eventually, AI is really about distribution and products. And for distribution and products to succeed, you need a strong single market. Europe does not have a strong single market. It's a very fragmented market. And if you are to scale, then it might be just easier to do it elsewhere.
One other topic that I love, maybe this is a bottleneck, maybe not, but before ChatGPT, basically AI research at these big tech companies was almost like academia. It was just like published, including the attention paper, to mention it again. Do you think that paper would be published today?
Hard to say, but given and what I've heard from the companies inside, right, probably was a massive delay.
With a massive delay. And is that a good thing or a bad thing that these
Bad.
companies? Yeah, why? Explain why is this secretive? Companies are always secretive. Why is it bad when it comes to AI?
So there's like few principles in my head, right? One is information wants to be free, right? So it doesn't matter that they don't publish. This information will dissipate, right? Either because other people will come up with the same idea and publish it, or because people talk, and if you're in Silicon Valley, you're at parties where literally every single company member present is pretty normal thing, and everybody talks some way, and you cannot contain that. People not signing with blood NDAs and having recorders, and this is again going to more 1984 style. So I think the reality is the information is spreading anyway. I think that DeepSeek was a really good example of. O1 came out, right? They have trained probably in a very similar way at OpenAI a reasoning model, and then DeepSeek, pretty sure probably very independently came up. I don't think there was much even information sharing, but the ideas were inspired and kind of and to be clear, there was a lot of research even before O1 on kind of chain of thought and search and reasoning, etc. So the ideas were there. It was really about really good engineering of systems and kind of, but if you look at DeepSeek paper, that paper is just one formula. The reasoning model is just this GRPO method is one formula. Containing that, keeping that internal, it just doesn't make sense. It's a very simple idea, and so for me, that is kind of main principle. And so I think the question is, and you mentioned distribution is very important. The reality is, right now, it's all about distribution and bringing this to people in a way that is productive, that's useful, that really turns it from, evil AI to productive friend and colleague that is actually helping them. And I think that's where we should be focused more versus trying to guard, a formula or a 5 parameters that actually, make sure this model is training correctly.
But do we know? How do we know if Peter, you're a researcher yourself. How do we know if somebody hasn't made some breakthrough that they're just not, giving out to the public at this point?
I guess we don't know.
All right.
So on this side, there's a very interesting experiment. Where let's imagine one of the labs achieved the level of AI where it can effectively penetrate any other cyber defense, and so can hack in. And the interesting thing about cyber is that it's very asymmetrical, right? You just need to find one vulnerability, and you need to protect yourself. You need to protect against every single thing, right? Against people and 0 days and hacks and networking, etc. Right? So now let's imagine one of these labs achieved that level, and they don't know if other labs achieved that level, right? And so now they need to decide what to do with this, right? They can do nothing, and potentially another lab uses it to hack into them and effectively sabotage their model and all of their research. They can go to government, and effectively this becomes a government level system that government uses for enforcement of its laws, or they can use it themselves to make sure that nobody else can achieve that level. So that's just an example of something that we probably want to have a more decentralized system where there's no kind of this game that can be played, and instead everybody effectively has equal access to the system, and the safety and kind of whatever rules applied on top are equal for everyone.
I mean, and on a more serious note, I mean, I think the reality is that we're still innovating in the same paradigm, and that's sort of what I said in the very beginning. I'm still optimistic, and I know this technology has created value. It continues to create more value going forward, but it's still the same paradigm that we've been working on for the past 5, 6, 7 decades. And whatever you want to call it, universal function approximators, A to B mappings, or something else, that's literally what we're working on. So I mean, we will see innovation, some innovation we don't know about, other innovation we know about, but eventually I would like to see more ambition in terms of moving from this current paradigm to new paradigms, and that's where I don't think we're seeing too much movement at the moment.
Are we, does anybody think we're getting really close, or do we all think it's like, you know, still however many years away to AGI, even though we can't define it?
Well, the goalposts keep moving, I think. So.
Right. I mean, we passed Turing test, and it wasn't like a big deal, right? Even though it was a big deal for many, many years. We effectively passed, like, hey, it is able to answer questions. I mean, like, I joined Google to work on question answering. The level we are at now was something we couldn't imagine, like, oh yeah, it is able to answer every question from a small, 70B model, right, without even access to internet sometimes. So I think, yeah, the goalposts are moving, but I mean, to kind of maybe go against what Peter is saying, I think we've started in this universal approximator model, but I think this is where the agentic system as a paradigm is different, because you're effectively giving access to tools, you're giving access to money, you're giving access to ability to hire other people. Like, we have an autonomous agent that can potentially go and hire another person to do something in real world for the agent, right? So you have an AI system that effectively is able to like act, collect more information, and do more things, and like that is definitely not a universal approximator anymore.
No, and I actually think we agree on that, but and that comes from the fact that I think we are creating a significant amount of value with this technology. But from a technology perspective, if you look at what we're doing, it's still sort of relying on the same underlying approach to eventually sort of make use of data in a highly supervised manner to eventually learn a certain set of functions. And yes, and then I think what we're seeing now is a sort of tremendous engineering effort on top of such approaches, which will continue to create more and more value.
Can we have everybody just do, Sarah, I want you to go, but just do your prediction for how many years we are away and why, really quick, before we run out of time?
Well, what I was going to say is that I think that we will never replace unique, original human thought. And that's maybe what you're pointing to, is that we're training on predetermined outcomes and data. But one thing that is inherently unpredictable are humans. And I don't know if that will ever be attained, because you can never replace human beings.
I mean, not to contradict this, but even the current training processes inside all these companies are effectively non-deterministic because they're based on the current state of the model. So like the training data sampled to train the model is different based on what this model knows and how it behaves at this point. So it's already learning closer to how humans learn by interacting with environment, by querying it and understanding what's not there, and then effectively more data fed based on that.
But it's still based on data that's given to it.
That data can be synthetically generated from another model based on the condition, or from from a synthetic environment where agents are running around, and from other different environments.
Agree to disagree.
I feel like, can I ask you, Bayang, one thing before we run out of time? Because I feel like you look at all the coding models out there and figure out which ones are best. Those are the ones that I think are the farthest along in terms of capability, really. Like, are we anywhere close to the finish line of whatever we want to call it?
I mean, if you had defined AGI with encoding like 3 years ago and said like, something reasonable, like it writes 95% of your code or something like that, then, in some sense we're already there. And I think we get to probably like 98 or 99% within the next year or so. But, the goalposts keep moving, and I think what you end up seeing is, it is just like with the AI models the early AI models that they trained to play chess, right? Like chess, AI has already outperformed humans on chess for many years, but humans with AI can still, win. So it's like the combination of humans wielding AI that perpetually moves out the goalpost, such that at any given point in history, I think we'll always think like, oh, there's still yet another thing that I'd like to automate that's kind of like boring or tedious. That is, the next generation's definition of existence.
I wish we could keep going.
Weekly contradict, but
very quickly.
Human with AI now loses to AI in chess.
Fair enough. I would say like
AI is actually human is a drag.
Chess
on
is
AI.
a very poor simulator of real life, and so to the extent that there's always going to be knowledge work that pertains to reality and this very complex reality that we live in.
I'd love to keep the conversation going, maybe with some drinks, but we can't. So thank you all for coming. It was great. Appreciate it.